Hi, welcome to How to Repair. If you have a problem with your built-in cooker, then this video is here to help you. I'll discuss how to diagnose the problem on the cooker and find the fault. We're working on a Belling cooker, but the fault-finding process applies to all makes. If your oven is not heating, one of the most common faults is people accidentally have their timer on auto. This may have occurred from a power cut or from even cleaning the cooker and accidentally hitting the knobs. The problem with this cooker is that the main oven is not heating. We turn the oven on to the fan assisted oven setting. You can see the thermostat light come on, but it is not drawing any ampage. The small amount of ampage that you can see being drawn was the fan running. But when we turn it to grill here, you can see that the element is drawing 8 amp. But we turn it back to oven, all you can see is 0.4 being drawn. Now, I do not expect you to have one of these meters to fix your cooker, so I'm going to talk you through how to find the fault. On most occasions this is normally down to a blown element, but on this cooker it is not the fault. In this video I'm going to teach you how to test the elements, the thermostat, the timer, the selector switch. There are also a couple of thermostats on the back of the cooker. One is a cutout stat and the other one is designed to control the cooling fan motor. And we'll also do a test and go through the common faults with the fan motors as well. All cookers come apart differently, but once you've got the cooker apart, you've got the fan motor, the fan oven element, the grill element, the light, and just tucked around the corner here are two small thermostats. One is a cutout stat and the other is a cycling stat. Now, when an oven's not heating, the first test you want to do is to make sure that the element is good. So we're doing a continuity test across the fan oven element, and as you can see we have continuity, therefore we have a field and therefore the element is good. We'll do it on the grill, but you already saw that on the amp meter at the beginning of the video, and as you can see we have continuity across the element and this element is also good. There is also a detailed video at the website and I've included it in the links above and below to test elements. Next we're going to look at these two little thermostats at the back of the cooker. They're not always fitted to all cookers. The one is a one-shot stat, which is a protection thermostat. It means if it overheats it will become open circuit. The other thermostat is no circuit on it, and this thermostat basically cycles at a certain pre-designated temperature. So say for example when your oven gets to 150 centigrade, this thermostat then has a circuit and kicks in the cooling fan. And the cooling fan is designed to keep the electrics and everything around the cooker cool with a flow of air going over. So we'll just test this cycling thermostat now, and as you can see looks exactly the same as the other one, and we'll have no continuity across the two terminals until it gets to a temperature. I think this thermostat kicks in at about 140 degrees. And what I'll do is just quickly use my lighter. You can see there's no circuit here, so if you have a problem with the cooling fan running continuously or the cooling fan does not run at all, there might be a problem with one of the thermostats. But do remember, all cookers do vary in the way that these thermostats work depending on the design. As you can see, once it got up to temperature it had a circuit, and as it cools down it'll click out and now we have open circuit. So that thermostat is working perfectly, but I just thought I'd quickly show you how these two thermostats are part of the oven's cycle. Although the main oven fan motor is good because it was running in the early part of this video, I'll still quickly show you how to do a test across the windings. It's a straightforward continuity or ohms reading test across the windings to make sure that you have a field. But the common problems that occur with fan motors is the bearings wear over a period of time, and this might decrease the speed that the motor runs at, restricting the flow of air over the fan oven element and stops the air circulating in the oven the way it should do. Sometimes oven elements can overheat because of this and blow more often than they should. We'll just do a continuity test across the motor to make sure the windings are good. We already saw the motor running in the early part of the video. But there we go. Now next we're going to test some of these components to make sure that electricity is getting through to them. This requires me doing a live test. You should never do a live test on an appliance unless you are competent with electrics. I have now connected the power supply up to the cooker and the fan motor is running and we have 235 volts. But the fan oven element is getting no electricity. This basically means that something is not supplying electricity to the fan oven element. Now I've disconnected the appliance from the electricity again, so it's safe to work on, and we're going to test the thermostat. The thermostat controls the oven by regulating the element by turning it on and off when needed. A simple test on a thermostat is to turn it to the off position with one of the terminals off, set your meter onto continuity. You shouldn't have a reading, but when you turn it to a temperature, you should end up with continuity across the two terminals. This means electricity will pass through to the element, and this one is good and there's no problems with it. You can find more information at the website with regards how thermostats work and other faults with thermostats. But next we're going to check the timer. On timers with auto start and stop feature, meaning that you're able to set a pre-designated time for the oven to start and stop, you normally have a relay on the back of them. These relays are what controls the electricity through to the other components, allowing the actual oven to start cooking at a certain time and stop cooking. On this timer I'm able to test the relay for continuity, and this is good, so we know that the fault lies with the selector switch. You can find out more about timers, by the way, at the website. Now here we have the new selector switch, and I'll swap over the new with the old, but basically you have a cam that rotates round and opens and shuts connections between different parts of the cooker. To get at the selector switch we need to remove the front facial panel, but to do this you need to remove the knobs and also the buttons that control the timer. Now you need to use a flat blade screwdriver to get behind these buttons. Do be very careful, as one, the buttons can break, and two, if you use too much force you can actually break the glass on the facial panel, which I have seen people do before. So once you've got these off, there is usually one screw either side or two screws either side which hold the facial panel onto the chassis of the cooker. While I'm taking this all off, do remember to subscribe to the channel, as that's what keeps us going and able to make these videos for you. And remember, we have a donate button on the top there on the information and in the description, and also some links through to the parts that you need to repair your cooker and to other tutorial guides. Selector switches normally just have two screws at the front that hold them in place. At this point I would make detailed notes of where the wires go, even to the point of getting some masking tape and actually numbering up all the individual wires, because sometimes there's more than one colour on the actual selector switch. As you can see here, there's 3 or 4 blues going to different parts of the cooker, so do make detailed notes. You can clearly see on this selector switch that the middle terminal has actually burnt part of the connector away. This went to the element, and this is what was the problem with this cooker. Now they can go for many reasons, but one of the common ones which I always advise people to do is the thermostat could be set to say 200 degrees, and people have a tendency to flick between the fan oven and the grill before turning the thermostat off. If you have a high load on a terminal and you're switching between the two, this causes a sparking effect which over a period of time can burn the selectors out. Take your time swapping over the wires, make sure you get it correct, as trying to find some of the technical wiring diagrams is usually very difficult to obtain. So do make sure you get it correct. I'll show you in a second how the cam actually works. There's links, as I said above, which will take you through to more detailed tutorials on other repairs on cookers, and also take you through to the website where we have tutorials on all types of appliances. I'll show you in more detail now how the selector switches work. They have a cam which raises and lowers different points joining two wires across them. Now this would allow, on the fan oven on this cooker, one of the connectors allows the electricity to pass through to the fan motor, but the other one allows it to go through to the thermostat and then to the element, and this was the one that was blown. So we'll bolt up the cooker now and we'll put it on test so you can see with my amp meter how the whole thing works now. While I'm putting this back together, I'll just run through all the faults with you. The first most common fault is the timer has been left on to auto. Then always check your elements first to make sure you have continuity and the elements are working correctly. If your electric is tripping in the household, this can be due to an element going to earth or a motor going to earth or possibly trapped wire. Again, you have faults with selector switches, faults with timers, faults with thermostats. All these can be found at the website, and we do have a live chat for our customers if you do need help. Now, as I said earlier, do be careful with these timer buttons. They just click into place. Now, we've turned the power back on. Make sure the cooker is set to manual. Now you can see that my amp meter here is got 239 volts and it's drawing 0 amps with the cooker off. So we'll turn it to the light. It's a very small amount of ampage for the light. And now the fan's running, but when we turn the thermostat you can see it's drawing 8.5 amps. That means that the fan is running and the element is drawing about 8.1 amp. Now we'll just flick it over onto grill. And as before, you can see it drawing just over 8 amp. And there you go. I hope you found this video helpful. Do remember to support the website. Thank you very much for watching this video, and I hope we helped you fix your cooker. Thanks for watching.